So it's a continuation of the topic. We will relate the intensity of the wave or the intensity of the light. So intensity of the wave or intensity of the light depends on two main factors. It depends on the power of the source, and it also depends on the distance from the source. So the intensity of the wave depends on the power of the source, and it also depends on the distance from the source. Example, if you are in a room, let's say you have two identical rooms of equal dimension, and you have two lamps are placed. So we place two lamps. This is lamp 1 and this is lamp 2. The lamp 1 is, or lamp A is having a power of 10 watts, and lamp B is having a power of 30 watts. And a person is standing here on the ground. Who will experience that the room is having a greater light intensity or the brighter? A or B? So both observers are at the same distance from the source. Like if observer A is like 10 meter away, the observer B is also 10 meter away. But which person experienced that the room is having a greater light intensity? Because the concept of light intensity means like how much energy we receive every second. So which person receive a greater amount of light intensity, the person B will receive a greater amount of light intensity. Or we can also say that the room B will appear to be brighter as compared to room A. So the amount of the light intensity which we receive or amount of wave which we receive every second on a unit area depends on the power of the source. Like when power means like how much energy is radiated every second, or how much joules of energy is coming out every second from the source, that will that is refers to the power of the source. So greater the power of the source, higher the or greater the light intensity, or we'll observe a brighter room in that case. It also depends on the distance from the source. Example, let's say we have a lamp is there. Example, this is a 30-watt lamp, and two observers are there. One is observer A at this position, another one is observer B at this position. Which observer will experience a greater light intensity or more light intensity? A or B?
A.
A. So it means that the intensity of the light is inversely proportional to distance from the source. If we are closer to the source, we'll observe a greater light intensity. Like example, if I have you can also take an example like electrical heater is there in a winter. When you switch on the electrical heater, if you are standing next to the heater, you will receive more energy per second on a unit area as compared to as you move away from the heater. So the if we are closer to the source, we'll receive a greater light intensity. And same thing, that intensity is directly proportional to power of the source. Greater the power of the source, greater the light intensity we receive. And intensity, other than the power of the source or the distance from the source, there is another factor which affect the intensity of the radiation or the wave, and that is amplitude. The amplitude can also affect the intensity. Intensity means like how much energy we receive on unit area in 1 second. So intensity of the radiation is directly proportional to amplitude square. Amplitude of the wave, like if I draw this wave, let's say this amplitude is 2 meters or 2 centimeter. And we have another wave with an amplitude Example 6 centimeter. So how many times the amplitude has changed? Like originally the amplitude was 2 centimeter and now the amplitude is 6 centimeters. So by how many times or by what factor the amplitude has changed? 2 becomes 6. By what factor the amplitude has changed?
3 times.
So amplitude has changed by 3. But what will happen to the intensity? Intensity is proportional to amplitude square. So it means if the amplitude is double, the intensity will increase by 4. If amplitude is 3 times, the intensity will increase by 9 times. So when we compare the intensity, if we call this is intensity like I1 and this is intensity I2. So what is the relation between them? That the second intensity will be 9 times the intensity of the first one. Why 9 times? Because we know the amplitude and intensity, they are directly proportional with square. So if the amplitude is double, intensity, what is the square of 2? Square of 2 is 4. So intensity increased by 4. If amplitude increased by factor 3, the intensity increased by factor 9 because square of 3 is 9. Same way, if amplitude increased by factor 4, the intensity increases by factor 16 because square of 4 is 16. So these are the three factors which can affect the intensity of the wave, the power of the source, higher or greater the power, greater the intensity. It depends on the distance. If we are further from the source, the intensity will decrease. And it is directly proportional to amplitude square. So greater, if we double the amplitude, intensity 4 times. If we triple the amplitude, intensity will be 9 times. Is it clear till this point? Anyone having a doubt or a question? Then I will write the formulas as well.
No.
Anyone
Clear.
having a doubt? Okay. Now the formulas, there are two formulas as we discussed the three factors. So two formulas are involved in one and the other amplitude is involved separately. So as we are discussing the relation between the so we know the intensity depends on the power of the source, the distance from the source, and the amplitude. So power and distance are included in the same formula. What is the relation between intensity, power, and distance? So intensity of the radiation is equals to power divided by 4 pi d square. This is a formula which relate the power, distance, and the intensity. You can see intensity is directly proportional to power. What does it mean? It means if I double the power, the intensity will be double. If I triple the power, the intensity will be 3 times. But what is the relation between intensity and the distance from the source? That intensity is inversely proportional to distance square. This is also called the inverse square relation. Inverse square relation means if you increase one quantity, the other quantity will decrease, but with a square. So if I double the distance, the intensity will decrease. By what factor? It will decrease by 4. If I triple the distance, intensity will also decrease, but by what factor? It will decrease by factor 9. So this is called an inverse square relation. If you multiply one, other will divide, but with a square. Like example, if a distance is double here, what will happen to intensity? Intensity will decrease by 4 because it's a square relation. If the distance is increased by 3, what will happen to intensity? It's an inverse relation. So one is increased, the other will decrease, but with a square. So what is the square of the 3? The square of the 3 is 9. So this will decrease by factor 9. So this is a relation between intensity and the distance. So intensity is equals to power 4 pi d square. And what is the relation between intensity and the amplitude of the wave? Intensity is directly proportional to amplitude square. So what does it means? It means like if an amplitude is double, the intensity will increase by 4. If an amplitude is 3 times, the intensity will increase by factor 9. If amplitude is 4 times, the intensity will decrease by factor 16, square of that number. And whenever in physics or in mathematical relation, if two quantities are directly proportional, so their ratio is constant. So I can also say that intensity divided by amplitude square will be equals to constant K. So if I have two waves, the first wave has an intensity I1 and amplitude A1. And I have a second wave which has an intensity I2 and amplitude A2. So when two quantities are directly proportional, the ratio is constant. So I can say the I1, like the first intensity divided by first amplitude square is equals to K. And here I can say I2 divided by the amplitude square is also equals to K. So because the two waves, their amplitude, there's a relation that the ratio between intensity and amplitude square is constant. So we can also form a relation. We can say I1, the first intensity, over A1 square, the first amplitude square, is equals to I2, the second intensity, divided by second amplitude square. So this is a formula which relate the amplitude and the intensity. And this is a formula which relate the power and the distance from the source. And it is valid for all kind of waves, light waves, sound waves. It is valid for all kind of waves. Is it clear?
Yes, sir. Yes.
Anyone having a doubt or a question till this point?
No, sir.
Okay. So this was about the intensity.